Okay, we are now recording. Sorry about that, but we should be good to go now. So does anybody have any questions on, on the specific questions on the homework? Okay, would you be able to go over where to shade on the number line, please? Sure. Do you have a specific question in mind? Because I can, just come up with a rough example off the top of my head, but if you have a specific question, then I'm sure that would probably be a little better than me just coming up with something. And yeah, Keji, we'll do 19 once I answer this one.
I don't have a specific question.
You don't? Okay. So if that's the case, I'll just, come up with a quick interval. So say we have the interval of like, sorry, say we have the interval going from like 3 to 7. And as you can see, just hypothetically with this interval, we are just using parentheses, say that was our final solution here. So as a result, we're not going to include the endpoints. So on our number line, we put 3, we put 7, right? Because these are the endpoints specified by the interval. And now notice it's going from 3 to 7 in the interval. All the numbers that are captured in this interval are going to be captured between 3 and 7. So 4, 5, 6, and all of the fractions and all of the irrational numbers that are between 3 and 7 are all going to get counted here, right? So what you do is, because it's parentheses and they're open circles, we do this. Again, we're not including our endpoints, and we shade in the region between our endpoints 3 and 7. So this number line representation is the representation of this interval here. You're saying you're talking about all of the numbers between 3 and 7 are solutions, and we are excluding 3 and 7 because parentheses tell us, to exclude them. If we also had something like from negative infinity to negative 2, bracket unioned with, 4 to infinity, because we've seen this come up a couple times, specifically with absolute values now. When we're working with absolute values with inequalities, we've seen this, this compound interval show up. So with this, once again, you look for the two numbers that we're really referencing here. And the two numbers that we're referencing are negative 2 and 4, right? Those are endpoints. And yeah, infinity and negative infinity are technically endpoints, but because they're just going off, forever, you're not stopping at a particular number. So you don't have to worry about, picking a particular number for infinity or negative infinity. So you just put down negative 2, put down 4. Okay, great. They're on your number line. Brackets tell us we are including the number. So close circle. So something like this. And now, again, reading this is the imperative part. Break it into two separate intervals. So we're talking about the negative infinity to negative 2. That means all of the negative numbers up until we hit negative 2, and we dead stop right there, right? We dead stop at negative 2, including that number. So we're talking about all the negative numbers up until we hit negative 2, and we stop at negative 2. And then we see that negative 1, 0, 1, 2, and 3, and all of the fractions and such are not listed in either of the intervals, right? Those aren't being counted, so we do not include those in a solution. But 4 to infinity is our next interval, and that means we're talking about all the numbers that start from 4 and that are larger than 4. So 5, 6, 7, so on and so forth. And so we shade this region here. And that's it. And now we have, as you can see, we have two different intervals that were compounded together, and we see that we have two different shaded areas. The number of intervals is directly going to correspond to the number of shaded areas that you have. Does that make sense? Are we okay on this?
Yeah, that makes sense. Thank you.
Great. Okay. Sure. So Keji's asking for 19, and then afterwards Kayla for 39. Absolutely. Okay, so let's start with 19 real quick. So 19 was a little bit tricky in the sense that we have square roots, but we actually end up seeing that the square roots really aren't too big of a deal with, with how this plays out. So 19 was you're supposed to find the distance between the points, and then after you found the distance between the points, find the midpoint between the segment, assuming that PQ was a line segment. So point P was square root of 2, 4, I think. Yeah, square root of 2, 4. And point Q was square root of 2 and 5 for its y-axis component. Okay, so again, distance. So my distance formula is going to be as follows. So d PQ, so the distance between points P and Q, and this is going to be equal to the square root of, okay, so this is why it being square roots really doesn't matter, because notice that we have the same exact number for both x elements. So we have the square root of 2 for the x element of P, and we have the square root of 2 for the x element of Q. That doesn't necessarily have to be the square root of 2 in this case, because if you think about it, if it's the same number matching either way and the x components are subtracted from each other, well, the same number minus the same number will always give you 0, right? If, for example, hypothetically, instead of them being square root of 2, they were both 7, well, 7 minus 7 is still 0, right? 8 minus 8 is still 0, -4 minus -4 is still 0, so it should make sense of 2 minus square root of 2 is going to give you 0 all the same. So just because the fact that we have square root of 2 for our x component really doesn't change how we treat this anyway. So again, we know that we start with our x components, and you just have to pick one point to go first, and you maintain that that one goes first. In this case, I'm just going to pick Q to go first because I see that Q has a larger y component than P, which means that when I subtract them, I'm going to get a positive number. If you don't have that foresight, totally fine, because we already talked about in the lecture how you're going to get the same result anyway. So we know that we're going to have square root of 2 minus square root of 2 squared plus, and now we're going to have 5 minus 4 squared. Well, once again, just like we talked about, the same number minus itself is just going to give you 0, right? Square root of 2 minus square root of 2 is 0. 0 squared is just 0. So, okay, we have that. And then 5 minus 4 is 1, and 1 squared is still just 1. So we have the square root of 1, which is just 1. And once again, we do not put plus or minus because for distance, when we're talking about length or distance, we only care about positive value. You can't have a negative length, you can't have a negative distance, so we just talk about the positive value of the square root of 1, which is 1. And that's it. Okay, and now for midpoint, so midpoint is, so the midpoint of line segment PQ or P and Q. Okay, remember that midpoint is the average of the components, right? So what are we doing? Well, we're going to take the, I can erase the 7s now. We're going to take the x components of each piece and add them together and then divide them by 2. Because again, that's an average, right? We're adding up 2 things and then dividing them by 2. And then we're doing the same thing for the y component as well. So we're going to add up the y components separately from the x components and then divide those by 2 as well. And we're going to have a new ordered pair. So our game plan is we're going to have the square root of 2 plus the square root of 2 divided by 2. And then our y components are 5 plus 4 divided by 2. Okay, let me call on somebody here just to see if somebody can help me simplify this. Gianna, can you help me with this? How am I going to add square root of 2 plus square root of 2? What do I get?
Do you get square root of 4 and then you do, actually, no, I don't know. I'm not sure how I got to it, but I got 2 and then square root of 2 on the top.
Yeah, so, okay, so, yeah, 2 square root of 2 is the correct answer. So think about it alternatively. So we see that we have something here plus the same something, right? So you could think about it as, okay, well, if I have x plus x, what are we really doing? When we add these, we're really just adding the coefficients, right? We get, so the coefficient of x is 1, the coefficient of this x is 1. We get 2x, right? If you're adding 3 plus 3, this is the same thing as adding the coefficient, right? It's the same thing as 2 times 3, which of course we know to be 6, right? So it should make sense then that if we're adding square root of 2 plus the square root of 2, we're just adding the same thing, right, twice. So the coefficient of each one of them is just 1. So we get 2 of the square root of 2, or 2 times square root of 2. Right? So that's going to be our top. We get 2 square root of 2 divided by 2. Okay? And 5 plus 4 is going to be 9, which is 9 over 2. And if you made that 4.5, that's fine. You could leave it as 9 halves. That's not a big deal. There's one last simplification that we can do, though, here. And the last simplification we can do is we see that we have a multiple of 2 in front of the square root of 2. And we're also dividing by 2. So this is, again, you can treat this as 2x divided by 2. Well, when you have 2x divided by 2, you're essentially just clearing the coefficient, right? You're getting rid of that 2. Well, that's exactly what's happening here as well. So what's going to happen is the only thing that's going to cancel is the 2 on the top and the 2 on the bottom. So we're just left with our final ordered pair of square root of 2 and 9 halves, or 4.5, however you left it. Does everybody understand this? Do we see why we're getting the coefficient of 2 in front of the square root of 2? Again, essentially, all you're doing with addition when you add, the same thing repetitively is you're essentially just multiplying it by, the number of times that you're adding it, right? That's what multiplication is. It's a series of additions. So all we did is we said, oh, well, since I have 1 square root of 2 plus another square root of 2, we really have 2 square root of 2. And that's just how we ended up getting 2 square root of 2 up top. And then again, by our midpoint formula, we divided everything by 2, so we got square root of 2 and 9 halves. I'm going to go ahead and assume you guys are all good with this one. If you do have questions, feel free to let me know. Otherwise, I'm going to move on to Kayla's question, which is number 39. Okay? All right, so let's erase this. And number 39, let's see. So the directions of 39 for 34 and 39 were you had to identify if the triangle that was created with the points was isosceles, equilateral, or scalene. And I gave you the definition of all three because I didn't expect you guys to know them. If off the top of your head, perhaps you haven't seen those before. So essentially all we're doing is we're going to find the distance of all 3 sides of the triangle. And then we're going to see if some of the sides are equal, if they're all different, or if all 3 are equal. If 2 of them are equal, then it's isosceles. If all 3 of them are equal, it's equilateral. And if all 3 of them are different sizes, then they're scalene. And that's it. So all you're really doing for 39 is you're just finding the distance 3 times, 3 different legs of the triangle. And then one last little thing at the end where you just check and see if any of them are equivalent. Okay, so let's list out the points that we have. So we have P, which is 1, -1. We have Q, which is -1, 1. And we have R, and R is negative square root of 3 and negative square root of 3. Okay, so I imagine that working with R was probably the biggest problem here, but we'll work, one at a time. So let's do PQ first, the distance of PQ. So PQ is going to be the distance between points P and Q, the whole thing, and it's going to be the x components squared, right? We're subtracting x components from each other, squaring it, adding it to the y components, which are also being subtracted from each other, squared. So it's up to you to decide which one you want to do first. It doesn't matter. Again, just remain consistent. So I'm going to pick P to go first. So what that means for me is I'm going to have 1 minus a -1 squared. The -1 is the x component of Q. So 1 minus -1 squared plus, and now I have -1 minus 1 squared. So -1 is the y component of P, and 1 is the y component of Q. Again, just remain consistent which one goes first. So I had P go first both times. Okay, so simplifying this down, we have 1 minus a -1, which is the same thing as 1 plus 1, right? So we get 2 squared, and 2 squared is just 4. So we have the square root of 4 plus, and now we have -1 minus 1, so it's becoming more negative. So it's -2, which is also being squared. So -2 squared is the same thing as 2 squared. We get 4 again. So we get 4 here. And so we know that we get square root of 8. And square root of 8 is, we know we can simplify this down, right? This is the same thing as when we factor it, 4 times 2. And that means we can make it 2 square root of 2. Okay, all I did to simplify the square root of 8 was I broke it up into its factors where one of them was a perfect square. And if we remember, when one of them is a perfect square, our plan is we're going to separate them into their own individual boxes. So we put square root of 2 into its own box, square root of 4 into its own box, and square root of 4 simplifies down to be just 2. Okay, so we can simplify square root of 8 and we get 2 square root of 2. So that's our distance for PQ. Okay, so now we have to do 2 more legs and figure out if this is in fact going to be, equivalent to anything else or not. Okay, so now let's do PR. So doing PR, let's see what we get. Okay, so this is going to be side PR, which is the distance between points P and R. Once again, distance formula. Okay, so it really won't matter which one you decide to go first. Once again, I'm going to pick P to go first just to kind of make my life a little bit easier. So we have 1 and then, we're starting with 1 minus the negative square root of 3 squared. Okay, then we're going to have, I forgot parentheses there. Then we're going to have plus, and we're going to have negative 1, right? The y component of P is negative 1. And it's still, the y component of R is also still just a negative square root of 3. So we have negative 1 minus a negative root 3. Okay. So at this point, I could see where, you guys might have gotten stuck. You guys might have tried to, obviously there's going to be some negatives that cancel out. So, the 2 negatives are going to cross out to be a positive. So for the first parentheses, it would be 1 plus square root of 3 squared. And again, at this point, I would imagine that some of you guys maybe turn to calculators to try to figure out what 1 plus square root of 3 is. You should probably try squaring it and then, doing the rest of the mess inside of, this big square root. And it probably came out to be like some really ugly decimal. I'm not really sure, we're going to figure that out together. But in any event, the way that we're going to handle this is we're going to simplify as much as we can. So we're going to make those 2 negatives positive. And then what we're going to see is we're going to have something in the form of a plus b squared. And we know how to handle a plus b squared, right? We know how to factor that. So when we have we know how to expand that. My mistake. So when we have something plus something being squared, we can always expand it. We don't have to have, a variable or an unknown in there. We can just do that with regular numbers. So let's get it into that form that we wanted in. So we're going to have here 1 plus square root of 3 squared plus, and over here we're going to have negative 1 plus square root of 3 squared. Right? You guys agree with me that these 2 negatives here are going to cross out to be positive, and then these 2 negatives here are also going to cross out to be positive. Okay, well, again, we see that we now have a plus b squared, and over here we also have a plus b squared. And if this makes you uncomfortable having a negative 1 here, what you could alternatively do is you could alternatively make this, you could switch the order to be square root of 3 minus 1 squared, right? We know that addition is commutative, same with subtraction. So while it's inside that parentheses, you can move things around so that way you have your positive square root of 3 go first and your negative 1 go second. And then your form, the expansion form that you're going to use instead for this one would just be a minus b squared, right? And once again, either way, you're going to end up with the same thing. I'm just saying that if it helps you think about it better, you could always move the numbers around. So let's work with the first one first. So the first one is the 1 plus square root of 3 squared. So let's see what we end up getting for that. So we know it's all under this big long square root, square root. I can't talk today. Okay, so a plus b squared. We know that that's going to expand out to be a squared plus 2ab plus b squared, right? I'll write this off to the side. Hopefully we all remember this. This is going back a little bit. So this is a squared plus 2ab plus b squared, right? Where a, in this case, is 1, and b is square root of 3. So we're just going to plug into our blueprint here, the, a squared plus 2ab plus b squared. So plugging in, well, a squared is 1 squared. So we get 1 squared plus 2 times a times b. So 2 times 1 times square root of 3. So 2 times 1 is still just 2. So I'm just going to write 2 times square root of 3 here. And then we have finally b squared, which is the plus square root of 3 squared. So cool, we've expanded the first one. And I can even simplify this already. What's 1 squared? Well, 1 squared is just 1, right? Okay. Before I continue, I'm just gonna give you guys a quick 5-second reprieve here. Does anybody have any questions on what I just did? So all I did was I canceled the negatives. I saw that it was in the form of some number plus some other number squared. So I saw that I could expand it. And we know that we could expand it with this blueprint. Is everybody okay with this? Yes, Amanda.
How do you know when to cancel out the negatives?
How do I know when to cancel out the negatives? The negatives are always going to cancel in pairs. I mean, you could leave it. You could have left it as 1 minus the negative square root of 3. And the blueprint that you could have used for that would have been a minus b squared, right? You would have had where a would have been 1 and b would have been negative square root of 3, right? Because notice we have that, the minus sign already in there. So you could have done this, but it's really just asking yourself, do you want to do more work? And obviously you're a little more prone to make a mistake if you're dealing with double negatives when you're carrying it through. So you're always going to try to cancel negatives whenever possible in pairs. So when we have, 1 minus a negative number, you're going to cancel it. When you have a negative divided by a negative, that's going to be a positive. And when you have a negative times a negative, that's also going to be a positive.
Okay, thank you.
Yep. Okay, so I'm going to assume that we're all good with just expanding this. So again, we got 1 plus 2 square root of 3 plus square root of 3 squared. And now we can even do one better here, right? Square root of 3 squared. What is this going to give us? Well, we have a square root and we have an exponent of 2. So we know that this is going to cross out, right? The square root and the square cancel out and we just are left with 3. So I'm just going to go ahead and write 3 here instead. Okay, if you did that on the next line, totally fine. I'm just going to write 3 here now. Okay, so that's the first one expanded. Let's go ahead and expand the next one, which is negative 1 plus square root of 3. Okay, so negative 1 plus square root of 3. Again, I'm just going to follow the a plus b squared formula, where a is going to be negative 1 instead. Okay, so plugging in. So we know that we're going to have, and I'll put a big old plus sign here, and you can put parentheses here if you want to try to keep this formulaic, to try to keep it separate. But since you're going to be adding everything up anyway, you don't really need the an additional parentheses. So we have a squared, which is negative 1. Oops, canceled out there. So negative 1 squared plus 2ab. So 2 times negative 1 times b, which is square root of 3. And then we have b squared again, and b is root 3 squared again. So we have square root of 3 squared. Okay. We see that we can do a lot of simplifications, right? Well, I'll write this on the next line. We have the square root of 1 plus 2 square root of 3 plus 3. And negative 1 squared is the same thing as 1 squared, right? Negatives are going to cancel. Going back to Amanda's question, right? We have negative 1 times negative 1. That's what the square means, which means negatives are going to drop out. We're just left with another plus 1. Okay, so over on this side, we now have 2 times negative 1 times square root of 3. So it's going to be almost the same thing as this term, except it's just going to be negative, right? Because we have the negative 1. So it's minus 2 square root of 3 here. And we already talked about what happens with square root of 3. Well, that's just going to give us 3. And what do we see that happens here? We have a really nice cancellation. We have a positive 2 square root of 3, and we have a negative 2 square root of 3. So these guys just drop out. We don't even have to worry about it. And now all there's left to do is just add up all the regular constants. So we have a 1 plus a 3 plus a 1 plus a 3. So that's 6 plus 2, which is 8. So we have the square root of 8. So equals square root of 8. And we know square root of 8 is 2 square root of 2, just like we determined up above. So really the key to doing this distance problem was just understanding that you could expand this And once you expanded this, you had some really nice cancellations. And you got rid of that root 3 problem that we were having. And then we just got 2 square root of 2 at the end when everything, canceled out. And again, keep in mind what our question was. Our original question was we had to find whether this is equilateral, scalene, or isosceles. Well, we already see that we have one side that's 2 square root of 2, and we just got another side that's 2 square root of 2. So it could still be equilateral because we didn't do that last piece yet, but it's definitely not scalene, right? Scalene is where all 3 sides are different, and we have 2 sides that are equal, so it's at least isosceles. Okay, so we have one last leg that we have to do, and the last leg that we have to do is, what did we just do? We did PR, right? So now we have to do QR. So QR, as you can already tell, should give you a very similar answer. And why can you already tell that? Well, P's components were 1 and -1, right? And Q's components are -1 and 1. Which means that the sign just got flipped from the X to the Y axis, but that should still give you a fairly similar response since we're going to be squaring anyway, right? Squaring is where, we're going to be making things positive regardless. So we're going to find that we're going to get basically the same answer anyway. So let's do QR real quick. Okay, so side QR is the distance between Q and R. We take the square root of the whole big thing, and I'm going to start with Q one more time. So Q is -1 for its X component, and we know all of R's components are negative square root of 3. So we have -1 minus -√3 squared. We have a plus, and the for Q squared. Okay, and now doing this, I'm sorry, this should have been a parentheses, not a 1. There we go. Okay, so we're going to have the same exact cancellations with negatives, right? So negatives are going to cancel one more time. I'll rewrite this once more. So we're going to have -1 plus square root of 3 squared. And over here, we're going to have 1 plus square root of 3 squared. And again, you look back at what we had over here, and we see we have the same exact terms, right? 1 plus square root of 3 squared, 1 plus square root of 3 squared. And we have -1 plus square root of 3 squared, and -1 plus square root of 3 squared, right? All that happened is that they just kind of switch places in the addition. They moved around, but because we know that addition is associative, they can totally do that, and we'll get the same answer. And so I'm just going to skip everything and say that we get 2 square root of 2. Again, if you feel like you need to do the calculations out, that's totally fine, but you're going to follow the exact same process that we did here. You're going to expand everything. You're going to get the exact same numbers that we got the first time we did this. And then because you're going to get the same numbers, you're going to get the same cancellations where positive 2 square root of 3 and -2 square root of 3 are going to cancel. And you just add up the remaining pieces. You get square root of 8, which simplifies to be 2 square root of 2. And now because every single side is equivalent, we have a 2 square root of 2 for side QR. We have 2 square root of 2 for side PR. And we have a 2 square root of 2 for side PQ. We can then deduce that this triangle PQR is in fact equilateral. Yes, Aline.
So for a test or a quiz, would you want us to go through the full problem instead of just skipping right to the 2 radical 2?
Are you talking about like at this point right here?
Yeah.
If you notice that this will give you the exact same result, sure, save work. Just give me like a short, like really short, quick sentence being like, this is redundant, or this is the same thing as up above. Just give me something to show that you understand why you don't have to do the work. But yeah, totally. If you can save yourself time and work, yeah, absolutely, take the shortcut.
Okay, thank you.
Yep. Again, I just need to see your level of understanding behind why we can do it. Okay, so that's really what's important to me. Okay, so hopefully we're all good with this one. Again, if you guys have further questions with this one, the biggest probably where I imagine a lot of you got stuck was right at this point where you had the two pieces being squared, the 1 plus square root of 3 squared and the negative 1 plus square root of 3 squared. And the trick that it took was just realizing that you could expand it. Once you expand it, this gets a lot easier. But if you tried actually adding things and subtracting things with the calculator, I'm sure this got incredibly messy super quickly, and you really weren't given like a super clear answer as far as, why this ended up being 2 squared root of 2. Okay, so we have some time left still. So Deborah with question 43. Sure, 43. Okay, so let's see what 43 is asking for. 43 says, find x such that the point x2, so the ordered pair x comma 2, is 5 units from 2 and negative 1. Okay, so ordered pair 2, negative 1. Okay, so think about what that is first asking of you, right? To be 5 units from something. So we're trying to find a point, right? So we already have the y component of it. The y component is 2. We're trying to find x, and once we find x, we have an ordered pair, right? Which means that we have a point on the coordinate plane. And it's known that this point is going to be 5 units. So its distance is going to be 5 units away from another point, which is 2, negative 1. So we know off the bat that we're going to be using distance formula. But what does it mean to be 5 units away? Well, it means, again, that the distance between the points is 5 units. So we already actually have an answer for distance. Normally, when we're solving distance, we set up, distance with some points, P and Q, and then, we do some rigmarole, and we finally arrive at, some answer. In this case, it would be 5, right? But we already know that the distance is 5, so all we have to do is set up the distance equation and set it equal to 5, because it's supposed to be 5 units away. So what is our distance formula? Again, distance formula is the square root of, and now there's technically 2 answers to this question, depending on how you set up the square root. I believe the 2 answers are -2 and 8, if I recall correctly, but we'll see. We're going to get one of them here. So the way that we set it up is, again, you're subtracting x components and you're subtracting y components. You square each of those, subtractions, and you're adding them together, right? So we're going to have x go first, because why not? So for x to go first, I'm just going to have x minus 2, right? 2 is the x component of the other ordered point. We square that. And this is going to be, we're adding, so we add over here, and now we're going to subtract our y components, right? So subtracting our y components, because we made x go first, now we have to make 2 go first. So we're going to have 2 minus a -1 squared. And keep in mind, what we should get is these points are supposed to be 5 units away from each other, right? So we set it equal to 5, because that's what our distance formula should have given us, right? Our distance formula would have told us when we did this originally, assuming we had some number instead of x, that these 2 ordered pairs would be 5 units apart. But because we already have that number, we can set this equation up so that 5 is equal to the distance formula. So since we have this equation set up now, well, I have this big square root. I don't want to deal with the square root. How do we get rid of a square root? Anybody, feel free. Just jump out, say it. I don't even care if you raise your hand. If I'm in an equation and I want to get rid of a square root. Yeah. Square both sides, exactly. All of you are right. All right, perfect. So we're going to square both sides. So squaring both sides, that means we're going to square this entire thing, and we're going to square 5. So, okay, there we go. Okay, so to square this entire side on the right, well, everything is underneath the square root, right? So all that's happening is the square is canceling with the root, and then everything else drops down. So we're left with x minus 2 squared plus 2, and I'm just going to simplify this because we know we can simplify this. 2 minus a -1 is the same thing as 1, and 2 plus 1 is 3 squared, so we'll just write 3 squared here. And over here, 5 squared is 25. Well, this is looking more and more like a quadratic, right? We have x minus something squared. When we expand that out, we know that we're going to get, some kind of quadratic. And 3 squared is just a constant that we could always move over to the other side, right? So 3 squared is 9. So I'm just going to subtract 9 from both sides. What's 25 minus 9? That's 16, right? So we have 16 is equal to x minus 2 squared. And this definitely looks like something that we've gone over before. We know how to consider this, right? You have your choice. You can either expand this out, do it the long way, get it into standard form. You can, then try to factor it or use the quadratic formula, but we can definitely do easier than that. And the easier way to do it is we say that we have, okay, I want to brute force this. I want to just consider squares here. I have something, my variable is being squared, right? It's x minus 2 being squared. If I want to undo that square, I'm just going to take the square root. And whatever I do to one side, I do to the other. So we take the square root, and we are left with x minus 2 on the right-hand side. Okay, now over here, we're also going to take the square root of 16, and we're going to be left with 4, but keep in mind that we're no longer solving for distance, right? Remember, I told you guys that when we're solving for distance, you only care about the positive value because distance can't be negative. But because we're solving for the component of a point, and we don't know where that point is, that point could be positive or negative, we should still include the plus or minus. We're solving for the component of the point, right? This is our goal here, not distance. We already know the distance. The distance is 5 units away. So we still need the plus or minus here. And now all there's left to do is add 2 to both sides to clear out the negative 2 on the right-hand side to get x by itself. So we have x over here. We have positive 2 plus or minus 4. And depending on what, depending on whether you add it or you subtract it, this gives you 2 different answers. So x, the solution set for that x component of the ordered point, is either 2 plus 4, which is 6, or 2 minus 4, which is negative 2. So what does this tell us? Well, this tells us that you have 2 possibilities. There's 2 ordered points on the entire coordinate plane whose distance is 5 units away from 2, negative 1. And those 2 points are either negative 2 and 2, right? The y component is staying the same, or 6 and 2. So again, your 2 ordered points, if you were writing them down, would be negative 2 and 2 or 6, 2. And because I only told you to find one, I believe I said find the point, right? If this were a quiz or a test and you only gave me one of them, that would totally be fine. If I were being like really strict, I would specifically say give me both points or give me both solutions. But either way, if you got to this point where you took the square root of 16 and you only ended up with the positive value of 4, again, just based on the way the question is written, because I took this directly from the textbook, I wouldn't be horribly upset if you just gave me, just the one answer. So you probably would have given me the positive 4, you would have added 2 to both sides, and you would have gotten x is equal to 6 and only 6, and that's totally fine if you, didn't get the negative 2 as well. Okay, so again, what was the key? Well, the key factor was understanding what this was really asking. It's saying find x, so we're trying to find the x component of a coordinate pair, or of an ordered pair, sorry, such that it's 5 units away from another pair. 5 units away implies distance, so we know that we're going to need our distance formula. We set things up in our distance formula, and because we already know that it's 5 units away, our distance formula is equal to 5. And then we just go through our normal problem solving things, solving for a variable, right? We have a square root, we undo the square root. And we have a quadratic, well, we can solve a quadratic in one of our ways that we know how to solve a quadratic. And this leads us to our final solutions, negative 2 and 6. Any further questions on that? Okay, so can we do the question after 43? Sure, the no-numbered question after 43, absolutely. We have time for 1, maybe 2 more. We'll see what happens. So the 2 questions after 43 were both using Pythagorean theorem. So we touched on Pythagorean theorem during the lecture. Pythagorean theorem is as follows. If you have a triangle, a squared, then the following should be true if it is a right triangle. Or if you're trying to prove that it's a right triangle, then the following should be true. A squared plus b squared is equal to c squared. So with the first question I actually just directly gave you the lengths. So the lengths are as follows. The lengths of the sides are, we have 5, 12, and 13, right? So all I'm asking you to do is verify if the triangle having these sides is a right triangle. And what that means is you're just going to be plugging them into a squared plus b squared is equal to c squared. Well, you might be a little confused as far as which numbers you're plugging in for which letters. Remember, it doesn't matter which numbers you plug into the legs as long as those are the legs of the triangle. The key is identifying the hypotenuse. And the hypotenuse is always going to be the largest side, the longest side. So if the triangle has sides 5, 12, and 13, 13 is the longest side, so C is equal to 13. And then A and B can either be, A can either be 5 or A could be 12, or B could be 5 or B could be 12. It doesn't matter because you're going to be squaring them and adding them together anyway. So as a result, it really shouldn't matter which one you pick. In this case, I'm just going to make A equal to 5 and B equal to 12. So now all there's left to do is just plug in and see if this checks out. If we get the same answer on both sides of the equation, or I'm sorry, the same number on both sides of the equation, then yeah, it's a right triangle and we verified it. If we don't, then it's not a right triangle, and we've also verified that. So either way, you're just checking to see if it's a right triangle. So we know, again, we have a squared plus b squared is equal to c squared. Plugging in our numbers, we have 5 squared plus 12 squared is equal to 13 squared. 5 squared is 25 plus 12 squared, which is 144, and 13 squared, I hope you guys know this. If you don't, calculators, Google, these are things, right? 13 squared, 169. And now all you have left to do is just add 25 to 144 and see what we get. And when adding 25 to 144, you get 100, 2 and 4 make 6, 5 and 4 make 9. 169 is equal to 169. That is, in fact, correct. So, yeah, a triangle with sides 5, 12, and 13 is, in fact, a right triangle. And that's all there is to it. So again, the hardest part of this one was probably just figuring out which length is your hypotenuse and then, plugging in after that. You also really needed to remember that right triangle, when you see right triangle, you think Pythagorean theorem, right? That should be the equation that comes to mind always. As far as the one that comes after this, the one that comes after this is similar to this one. But the difference is instead of giving you the lengths, I gave you the coordinate points, so the vertices of the triangle. And what you had to do for that one is before you could jump right to a squared plus b squared is equal to c squared, you first distance formula to find the distance or the length of each side, and then and only then could you plug those sides into a squared plus b squared is equal to c squared. So does anybody have any questions on this right here, just using the Pythagorean theorem? Because we've already done quite a bit with distance with the examples that we did today. So I imagine that, the next question, just combining the ideas, as long as you understand the individual ones, really aren't so bad. It's just you're going to be doing the distance formula 3 times, and then once you have the 3 sides, you plug into the Pythagorean theorem. But if you have questions, please let me know now. We still have a couple minutes left. Okay, so once again, I generally take silence as you guys have your thumbs up. So this is all good. So if this is all good, I'm going to go ahead and clear the canvas. I'm going to give you guys back 3 minutes of your day. So instead of ending at 11:50, we'll end now. The one last thing that I'm going to say before we end class is please make sure that you're doing your own work. It's very important to me you're doing your own work. Regardless of what grade you get, you're doing your own work. Because if you don't do your own work and I catch you, again, goes up higher than me, right? So I'm giving everybody or anybody who, may have done some, misconduct on the last quiz, I'm giving you till 4 p.m. today, just like my email said, to get in touch with me and let me know what happened, okay? Otherwise, you guys, for everybody else, you'll be getting your quizzes back 4 p.m. today, okay? Office hours are 4:15 to 5:15. So I'm going to try to send out all those quizzes before office hours or, just shortly into office hours. And that's about it. All right, guys. So project packet, this is my only, last bulletin about it. You guys are now up to the point to where you could do 3 of the 10 questions, I believe. So the first 3 questions, because we got through absolute values. So take a look at the project packet if you haven't. Try to stay up to date with it, and that's about it. All right, I'm going to end the recording now. Enjoy the rest of your day, guys. I will see you all on Wednesday.